Hello everyone. My name is Ishant Kumar, and today we'll be discussing about a very interesting problem, which is going to be clock and strings. So, let's read the problem. There is a clock labeled with the numbers 1 through 12 in clockwise order, as shown below. Alice and Bob have four distinct integers A, B, C, D, not more than 12. Alice ties a red string connecting A and B, and Bob ties a blue string connecting C and D. Do the strings intersect? Okay, let's look at the input and output. The first line contains a single integer t, the number of test cases. The number of test cases is approved 5940, which is almost 6000 number of test cases. And each test case will contain distinct integers A, B, C, D. And we have to, as an output, we have to give yes if the strings intersect and no if the strings do not intersect. So let's see what the problem is trying to say. So the problem is trying to say that we are given 4 points A, B, C and D. Since they are given on a clock, so the points will lie between 1 to 12, and the point AB denotes Alice. It means the points AB will be Alice point. Wherever the AB lies, Alice will tie a red line from point A to point B, and similarly the point CD is belongs to Bob, and wherever the point CD lies, Bob will tie a blue line. We have to see if the red lines tied by the Alice and the blue lines tied by Bob intersect each other or not. That's what is asked in the question. Let's see the example that is given here. For the first example, A, B, C, D is given 2, 9, 10 or 6. As you can see here, uh, A and B, the points A and B, which is Alice points, are 2 and 9. So from 2 to 9, Alice had tied a red line, and the point CD, which belongs to Bob, which is 10 and 6. So Bob has tied a blue line from 6 to 10, and in this example, both the lines intersect each other. It means 2, 9 and 6, 10 will be intersecting each others. So the output for this example will be yes. This is the first example. So the output is yes. So similarly, let's take three examples here and let's try to solve it and observe if there's any pattern in this problem. Yeah. So for the first test case, we have let's do one thing. A, B, C, D. Now, yeah, that's more clear. So for the first test case, we have 3, 8, 9 and 1. So the first 2 points will be A and B, which belongs to Alice. So let's mark it 3 and 8. So 3 to 8 will be here, and 9 and 1, it will belong to Bob. So 9 and 1 will be from here. So in the first test case, the lines do not intersect. So it will be a no for the first test case. Let's move on to the second one. For the second, AB is 1, 2. 1 and 2, it will come, I guess, like this. And CD is 3, 4. So this will also not intersect 3, 4 because it's almost adjacent to each other's. Let's take the third test case. For Alice, we have given 5 and 3, so 5 and 3 will come here. And for Bob, we have given 4 and 12. This will intersect each other. 4 and 12 like this. So in the second test case, it is not intersecting. In the third test case, it is intersecting. So the point to be observed here is that If you look closely, uh, this in this test case, the lines are intersecting because one of the Bob's point lies between one of Alice's point. Uh, in simple language, like Bob's points are 5 and 3, which is this, and 4, which is Bob's point. It lies between Alice's point. That's why we can see that it is intersecting. Let's see for the other test cases. For the first test case, it is not intersecting. 3 and 8 are Alice's point. 3 and 8, and then we have 9 and 1. 9 and 1. Both the points do not lie between uh, below Alice's point or above Alice's point, which in result we are seeing that these two lines do not intersect. And for the second test case, both the all the points are adjacent to each other. They do not lie between. But in the third case, we can observe it really carefully that the Bob's point, it lies between Alice's point. That's why it is intersecting. Both the lines will be intersecting. It is seen in the first test case also. Yeah, so here, let me just do this. Uh, so in this test case, 2, 9, 6, 10, 2 and 9 will be Alice's point AB, and 6, 10 will be Bob's point, and the 6 lies between 2 and 9. That's why these 2 points are again intersecting, these two lines are intersecting. That's the thing that we can observe here. So how are we going to code it? So to code it, we have to check. We'll do one thing. Uh, we'll start an iteration from 1 all the way to 12 because there's only 12 number on the clock, and wherever we find Alice's first point, we'll start counting from there. We'll start from there. Let's say it is for this test case, it is 2. And next, what we'll do is that wherever between 1 to 12 we find Alice's point, will return red. Will return red as a string value. And after that, if we find after Alice's point, if we find Bob's point just after that, let's say it is 6. For Bob's point, points will return blue, and after that, if we find another Alice's point, which is 9, will again return red, and the lastly it will be Bob's point, which is 10. So Bob's point will return blue. So blue. So this will be our string, and let's say for some test case we get first we get Bob's point, then we get uh, Alice's point, then we are getting again Bob's point, B and B, then we get again Alice's point. So for these two strings, if we find these two strings in the iteration, it means the lines will be intersecting. The lines will intersect each other. Uh, so it is for intersecting. Let's check for this test case if my logic is good to go or not. So in here, so for Alice's point, we are starting with 3. So first we'll take red. Okay, then again after that we are getting 8, which is again Alice's point, so we'll go with red. After that we're getting 9, which is Bob's point, so we'll get 9 blue. After that we get Bob's point, which will be blue. So let's say for some test case, we get Bob's point before Alice's point, so it will be blue, blue, red, red. So if we get a string like any of these two, the points, the lines will not intersect, because for the lines to intersect, one of the Bob's point or one of the Alice's point should lie between somewhere here, between Alice's point or between Bob's point. It is necessary. If it's not found, then the lines will never intersect. So for this, if we are getting this string, the points will not intersect, and if we get any of these two strings, the point will intersect and will return a yes, and for this string will return a no. So let's look at the code that I've written now. So here we've taken t, which is t is the number of test case. T will be the number of test cases. It is almost up to 6,000, and under each test case will be given 4 points A, B, C, D, and A, B, C, D lies up to 12, from 1 to 12. So up till here we are taking just the input. Here I've declared a string answer, and I've started the iteration from 1 because the clock doesn't have the number 0. So I'm iterating from 1 to 12, and if any number at any point I find I equal to A or I equal to B, which means I find Bob's point, I'll return red to the string. And if at any point I find Bob's point, which will be equal to C or will be equal to D, I'll return blue. And after the iteration ends, because it is only 12 point though, so the iteration will end quickly. And after that, I'm checking if answers the string value. If the string value I'm getting as red, blue, which means the lines will intersect, or the string value is blue, red, then also the line will intersect. For any other value, the lines will not intersect. So let's try to run it for the first test case, which is given in the problem. Let's copy the first test case. We've given a total of 15 test cases. So let's compare it side by side. So for the first, which is given in the example also, we are getting yes. For the second two, we are getting two no's. Then we are getting two yes. And at last we are getting four yes. Other than that, all are no. Okay, so for the test case, we are getting all clear, and I've tried submitting the code, and it has been accepted. It is the same code which is accepted by the forces. So let's talk about the time complexity of the problem. So since the biggest number that we can pull out of this will be number of test cases, which is up to 1,000. The number of A, B, C, D values are fixed. It can most probably up to be 12, so that won't be anything to worry about. And I've used one iteration here. Since the number of test cases t is the only thing, only the largest value, so the time complexity of this code will depend upon t. City, it will be VO of t. It will totally depend on the number of test cases that we are getting, and that's solving the problem. Uh, yeah, thank you.